Did you have a chance to look at the assignment?
We looked at it and we tried to solve like 2 questions.
So let's look at each of the problems, okay?
Okay. Do we use this class period, the extra class tomorrow, and class Wednesday to go over homework?
Please.
Let's get started. Let's start this class. So, all right. So now pay attention. Please pay attention. Tell me the first problem.
Write the equation for
Okay.
our expression.
So is this difficult?
This one? I haven't attempted yet.
How can you not attempt writing an expression? You cannot write an expression. You don't have to attempt there. So did you attempt it, Paris? Did you attempt writing an expression?
I skipped that one because I figured that wasn't like a big deal. I just went to the ones where you had to like try to work out.
But you have to write an expression. How many of you all wrote an expression?
We know how to write script. That's why
How many of you all wrote an expression?
We don't.
No, you said you skipped.
No, see, I skipped it because it wasn't a problem. I went to the ones that we had to work out.
No. Don't give me a reason. Don't give me an excuse. Tell me how many of you all wrote. I'm asking a simple question. How many of you all wrote the expression? None of you wrote the expression. Justin wrote the expression. Okay.
That's not what I did.
No, I'm just asking a question. Answer my question.
I didn't write it.
Okay. So why did you write it? Then that means you did not try it. You did not do anything in regards to the. You did not try the homework.
We did try. I told you we went to the problem to take fall.
Did you write an expression? Do you know what an expression is? Andrew?
So when you say the line expression, yes.
Did you write the expression? Did you just go through the notes or go through the textbook or go through the lecture? I have given that expression several times. And I've mentioned that to you. So if you cannot write the expression, I just explained that to you last class itself. What that expression is, exact question I explained it to you. Exact question I explained it to you. What is the expression? Why is it a special case? What does the question say? Write an expression for orbit equation, right?
Yeah.
And explain why it is a special case of. Right. This is exactly what I explained in the lecture. You guys remember?
Yeah, I remember you writing this.
Right. So you should have written that expression. If you haven't written that means that you did not try the homework.
So you're talking about the R equals A squared U?
Yes. That's what the expression is.
No.
Why is it a special case? Why is Kepler's law a special case? I also gave it to you in the special case. Why it's a special case? What is the special case? Huh? Yes, that's it.
I remember it. I didn't forget it.
You should write it down. Okay. Let's look at the next one.
Consider an Earth-observing satellite a circular orbit with velocity v circular, given by v circular equals the square root of u over r. For the satellite to escape Earth's gravitational pull, epsilon equals 0, show that the escape velocity v escape is needed is 1.41 times v circular, i.e. v escape equals 1.41 v circular.
Okay. So now, this I would agree that it's not taught. It was not taught. Okay. So what happens is, escape now. We discussed circular orbits and we discussed elliptical orbits in class on Friday. Okay. I immediately put it up on YouTube. Did you guys review that lecture? How many of you all sincerely reviewed that lecture or went through that lecture on Friday?
I wasn't here. I was at the time.
No, I uploaded the lecture on YouTube. Did you go through the lecture on YouTube?
No, I remember that.
So if you don't review the lecture, then it will not help. Notes alone will not help. It's just 30-40 minutes lecture. How many lectures did you review over the weekend?
I reviewed about a good 5.
Okay. How about the rest of you? Anybody reviewed lectures?
I did not.
I did not at the district conference. I gave my speech there.
You should review lectures, Jessica.
No, because Saturday I got back at 10 and I left at 3 a.m. And Sunday I was doing econ.
Okay.
That was on my plate today.
Alright, so see the midterm, I have to give you a midterm grade. Otherwise I'll be questioned. Okay. If without your midterm exam, how can I grade you?
That's one. That's one and homework.
You understand the midterm also has
I mean,
Has that
we
slot.
had that before last semester. One of our classes we had.
But
That's-
I don't think everybody can take that hit.
No, I'm just saying, like, we did it in structured one, but we didn't have that many tests. I mean, not structured one, structured two, I think. We didn't have that many tests, so we just used whatever's grade we had that upcoming year.
We cannot do that. So midterm, there is a slot allocated by the administration. You see that if you look at in the calendar, it says 10th and 11th is specifically dedicated for midterm. If I don't give you a midterm, I will get an email from
Well, can you give us like a quiz and then use that as midterm and then give us this after?
And again, it's not about you alone. It's about everybody is not saying that.
I agree with it.
But there are people who want to take midterm. Even if there is one person who wants to take midterm, the first exam, not everybody has done well, right? So they want to show better performance in the midterm. It will be unfair to them.
That's why they want to take it after so they can be better prepared.
That is not the allocated time.
Dr. Summers, can we discuss this after budget, please?
Yeah. That's what we have to do. Okay. So if you look at
Because I mean, the grades aren't due until the 18th of October.
right, so if once you come back Tuesday when the grades are due. You understand?
Wednesday, they do Wednesday. So when we come back on Monday, right?
Right. So Monday you come back, you take the test, and you immediately grade it. Let's discuss the lecture first. Okay. Let's discuss the lecture. Let's figure out how we can work out this. Okay. So parabolic orbits. So until now, we've discussed circular E equal to 0 and elliptic. Okay. Now these two are closed orbits. Okay. Everybody agrees, everybody understands what closed orbits are?
Yeah.
It's closest. Okay. It is closed orbit. Here, this E epsilon closed orbit just means this epsilon is negative. Okay. Where does this epsilon appear? What expression does this epsilon appear? You guys remember?
0. Is V equal?
Yes, that's what I want. Epsilon equal to v square over 2 minus mu over this is where epsilon appears. Okay, this is this V1 equation. Or this is conservation of total mechanical energy.
Yes.
Okay. So what happens here is this energy is negative, means here it's negative, right? You see this epsilon as negative. That means it cannot, as long as this energy is negative, it cannot escape.
Yes.
The energy of the orbit,
Meaning that the gravity is overcoming.
yes.
Oh, okay.
Right. Okay. So here, so if you look at either circular orbits or elliptical orbits, okay? As long as this energy component is negative, right? The satellite will keep on orbiting. In parabolic orbits, what is E?
Assuming it's positive.
What is E for parabolic orbit? Anybody?
Greater than 0.
E
Equals one.
Oh, E.
Equals one.
Yes.
equals 1. Yes. Now tell me what is epsilon?
Greater than 0.
Huh?
Greater than 0. This is escape.
It is 0.
It is 0.
Yes.
Okay, that's different.
So what happens is, it has just enough energy. What this means is, it has just enough energy to escape. Okay? And so the orbit itself will look like this. Now, how do you get into this orbit? It's a very interesting. How do you get into any orbit?
You get to the orbit.
Right.
When you go, you want to go with the atmosphere. So kind of
Right. You go this way and right.
Right.
You've heard about this escape velocity, right?
Yes.
Everybody had heard about escape velocity. Is this constant? Is this constant?
A constant or is it a constant?
Is it a constant?
Doesn't it depend on the situation?
Yes.
Just like with the all these circulars?
Yes.
Is this where you
So it depends on. So what's going to happen is, think about it. Okay. You typically, if you want to escape, if you want to so what you'll do is, this is a circular orbit, okay? This is the parabolic orbit. And this is your, what is this point?
focus.
It is the focus.
Sensor and
Yes, the occupied focus, unoccupied focus, and sensor. All 3 points are the same for circular orbits. We discussed this, right? So you're going to go here. You're first going to get into this orbit. Can you escape from Earth, starting from Earth?
He's starting our stop
Can you escape? Would you want to escape starting from Earth?
No,
No.
Why not?
require a lot of energy.
You require way too much energy, right? You want to. Why do we use rockets or launch vehicles?
Just escape right with the atmosphere.
As to escape the atmosphere. The rockets are largely required to escape the atmosphere or to overcome the atmospheric gravity.
Yes.
Once you're in space,
Just use Earth's gravity.
yes, not Earth's gravity, but you don't need as much energy. Okay, you need much less energy once you have escaped that atmospheric gravity. Okay, the large amount of fuel is required largely to overcome atmospheric gravity.
Yes.
Okay. Gravitational pull does not vary a whole lot. Whether you are on the surface or let's say 200, 300 kilometer orbit.
Really?
Yes, so that is something I want you to think. What is gravitational force a function of?
Mass.
Hmm?
Mass.
What is the law which tells you what gravitational force is a function?
I'm not sure. I'm not sure.
I gave you that expression again.
No, sure.
Huh?
Is it second?
No.
Gravitational force. What do you know about gravitational force? You don't know the law of gravity?
I mean, I can explain it.
Huh? Universal law of gravitation. Yes. Universal law of gravitation will give you the what gravitational force is a function of. What is it a function of?
Hot.
Yes. So if you look at gravitational force itself, you remember this, right? You have to remember this. You cannot forget this, right? The force of attraction between any two bodies is directly proportional to the products of the masses and inversely proportional to the distance. Okay. Now, how much thrust do you need if you want to escape this gravity, this force? What is the thrust required? Thrust required would be, if you're purely talking about escaping gravity, not atmosphere, huh?
No other forces.
No other forces. If you are able to apply this much force, or little more than that, would you escape?
Yes.
Right? So here, if you are on the surface, does this change?
No.
Two bodies. Does this change? Does this change? What is this? If you are on the surface,
That's Earth.
Earth's mass. Does it change?
No.
If you're looking at what is the body,
Satellite. Or
satellite or even a rocket, right? Does it change?
No.
Whether your surface or
Right.
the mass does not change. The weight changes. The mass does not change. The total quantity,
But you're burning your mass.
right? But let's look at purely something
It remains relative as a relatively constant.
relative. So let's say whether you're starting from ground or starting from this, the total mass is the same, right?
Okay.
What is this distance now for the surface?
That's changing.
That is the
Distance between you and the M1 and M2, right?
yes. So what is that distance?
On the surface.
Yeah, Radius of Earth.
Radius of-
it's the radius of Earth,
from the center.
which is I think 6,3. I forget the number. 6,3. 6,400. Okay, let's just.
What's subscript is that?
Hmm?
What's subscript?
Earth.
It's just E.
Yeah.
Okay.
What?
This
6,400.
kilometers.
Across the circle, 2 months.
Okay. So you are with me?
Yes.
For the surface, this is the distance. If you're above, let's say 200, 300 kilometers, how much do you add?
200, 300 kilometers.
200, 300 kilometers, right? Is it a whole lot different?
No.
It's not a whole lot different. You see that?
Yes, so technically the force of gravity isn't that much different.
So the gravitational, whenever somebody tells you or somebody asks you, there is no gravity in space, that is a false statement. The gravitational force, especially on the space station, okay, is not a whole lot different from what it is on the surface. It is different, it is significantly different enough to overcome so we can float.
Good question.
Mm.
Which one are you saying is the one on Earth? Which one are you saying is the one like in space? Is that what you're saying for that? For those numbers?
This is the space.
Okay.
This is the surface.
Okay. And you said the R was the radius. Like,
Radius of the Earth.
Okay.
So you just add the altitude to that.
So it's not very big, but it's big enough that you can suddenly start floating.
Yes.
So there's like a few, the acceleration, the force required for me to suddenly start floating on Earth isn't that big. Okay.
That so we are used to that. If you're used to lifting a certain weight, okay, then you reduce that weight by a certain percentage, 10% or. Don't you feel a significant difference?
Yes.
That is what is happening.
Okay.
Okay. So this now. So what you do is you go. Your rocket goes like this, and it will take this curve. Okay. It will first get into this circular orbit.
Okay.
Okay, if you want to escape.
Right.
And then when it is here, it will shoot out. Yes. So if it will do a shoot out to go into this.
So it shoots out and goes into the parabolic curve?
It goes into a parabolic orbit.
Okay.
Okay. So the thrust, the fuel will be burnt in this direction. The thrust will propel it into this wave.
Okay.
So I have a question about the lecture we had on Thursday, Wednesday, something like that. We were going over Kepler's laws and like the second law where if the distance is larger, your velocity changes.
Hmm.
So I had a question about that. So can you try that over here real quick? Like the focus and all that stuff. So my question is, if the velocity change is relative to the distance, right? That's true. Why don't we feel a change? Like, doesn't Einstein's law state that? Like,
So Einstein's law, we don't talk about Einstein's law when we're talking about orbital mechanics.
But isn't it true? Like, if your acceleration changes,
Only if your acceleration, Einstein's laws are good, or you want to use them only if you're traveling at the speed of light.
Okay, so then a change in acceleration wouldn't be felt by the other.
So we don't like Einstein when it comes to orbital mechanics.
Good question.
Yes. So now let me just finish this. Okay. So now when this E is equal to 0, okay, when the energy is equal to 0, you have just enough energy to escape Earth's gravitational pull, but not go beyond that. You get it?
No. What do you mean not go beyond what?
So you want to escape and keep going.
Yes.
But if you escape and you're still, once you escape, right? If you don't have any more energy left, whatever energy you had, you used it here.
To escape.
Yeah.
So you come right back.
You don't come back.
Yes.
So what you'll do is,
That's
So it's like you just escape and then you just
yeah,
go
your
off.
saddle, you'll be here. So this is going like this, okay? Around the sun. This is Earth. Alright? This is just here. It's almost like it's trying to catch up.
Okay, so but relative, so it stays still relative to the Earth? Or
Yes, relative
space?
to Earth.
So then you're just stuck.
Yes, yeah, exactly. It does that.
Okay.
You see that? It is Earth is doing this around sun. This is trying to just catch, but it is not able to do it. You understand? That is a lost in space problem.
So it's still like rotating, but not with Earth, like way far.
It's not, yes, it's not rotating around, it's practically rotating around sun.
Oh, okay, so it's just like Earth right here. This is just going on this whole thing, but it's
Yeah.
going at the same. Okay.
Yeah. So it almost becomes a linear path.
Okay.
Okay. Now what you want to know is, with regard to that problem, use this equation, okay? Think about this equation. If this becomes 0, what is this V?
That's what we.
So pay attention here, guys. If epsilon equal to 0 in this Vy equation, what does V become?
0.
V will then be
V becomes VSK.
So you're not, okay, I see what you're saying.
So
So
the last.
You got that?
Oh yeah, because now you're definitely
You have escaped now.
Yeah. Okay.
There is a relative velocity. The velocity is not 0. Okay?
Wait, can you explain that out again?
Then this energy is negative. What is this V?
This would be what is it? Circle. Like
It's either circular or
yeah, or
Oh, okay.
elliptical.
Does that go to the closed orbit?
Huh?
Does that go around the closed orbit?
This one?
Yeah, I mean, up there you got E or epsilon is less than 0.
Yes, this is for closed orbits. So these two are the closed orbits. You understand why these are closed?
So, okay, yeah, so if the epsilon is 0 on orbit is not close. I mean, it is close.
Where is epsilon 0?
No, like what you just asked me, you said if it's 0, so it would be close.
Yes, so it is here. This epsilon is, what is epsilon here?
There is closed.
Yes, so it is negative.
Okay, so if it's 0.
For this, epsilon is?
0 is open.
Okay. The energy, there is not enough, there is no potential energy, there is no kinetic energy. Okay. So this becomes V escape minus, this becomes mu over R. So understand what is happening, guys, okay? Just pay attention here. Let's say the satellite is in the circular orbit. Okay? If it is in a circular orbit, what is the velocity here?
The velocity there.
It's in a circular orbit. What is V?
Whatever it does.
Wherever you launch off.
Huh? It's V circular. Correct?
Oh, yeah.
If it's in a circular orbit, the velocity is V circular.
Right.
Yes.
What do you need to do to get into that? Increase that V circular. You see that?
Yes.
By how much do you increase?
Just enough. Enough to
Whatever
overcome
interior,
zero.
that's what
That's what it says, that's what the problem is. How much do you increase? Okay? So
So we
here,
said how much you need to,
here, just look at this, okay? This implies, you can say V escape square is equal to mu over R, 2 mu over R,
Okay.
okay? And V escape is root of mu over R. And you're doing this, what is root of mu over R? I gave you root of mu over R.
it's just gonna be, you, wait,
Look at your notes. V circle. This is root 2 V circle. What is root 2?
It's like, that's the 1.4.
1.4.
Oh, okay.
You got it?
Yes.
So this is such a beautiful concept. Okay. You get this if you can explain this to anybody. It is such a beautiful concept. You, regardless of what circular orbit you are in, you increase the velocity by 41%, what will happen?
You're done.
You're gone. Regardless of, so does it matter what,
The mass.
so is this, yes, so if you're able to, you have to correlate it, mass, it depends on mass, but if you correlate that to your, how much thrust is required and all that. But the thing is, if you increase the velocity by 41%, if you increase it by 50%,
You're gone.
if you increase it, now here's another question. If you increase it by exactly that 41%, what orbit will you go in?
Elliptic.
Parabola.
Oh, because that's the other part. Okay.
If you increase it by 50%, what will happen?
Elliptic.
No. You'll go to hyperbolic.
I mean, yeah, I'm sorry, I meant to say hyperbolic.
Yes. You see that?
So,
no, can you explain that?
yeah, because now you're really going.
Can you go back, explain it again?
So here is, so this mu r, is this r the same for whether you are looking, here is the satellite, okay?
Okay,
This is the r.
okay,
This r, it could be, it's for the circular orbit or the parabolic orbit, right?
right,
You see that?
right.
What determines whether it's a circular orbit or a parabolic orbit? This quantity, v. V determines whether it's a parabolic orbit or circular orbit.
Okay,
So this mu, if it's a circular orbit, okay, it will just keep on going in a circle.
right,
Here you are at a circular orbit, you increase it by 41%.
What do you mean, 41?
If you're, let's say, let's look at it in the context of driving a vehicle. Okay,
okay,
you're driving at 100 miles an hour.
right.
What orbit you're in?
If you drive,
Contextually, take it to space. You're driving at 100 miles an hour. That is V circular. Okay, got it?
Yes.
You'll be in a
Circular orbit.
circular orbit.
Okay.
Think about these NASCAR or Formula 1.
Okay,
So you're driving. Your this thing is 100 miles.
okay,
You increase it to 141.
You're going to crash into a bunch of people.
oh, I see what you're saying.
You just get out of that
Yeah.
and go into a parabolic orbit.
Yes. Okay.
you just pull more G's.
See it in the context of this. You're doing this 100 miles, 100 miles, 100 miles, 100 miles. Okay. You increase it by 41%,
And you hear,
you'll escape. You'll escape that ring.
Okay,
That is what this says.
yeah, okay, so just root 2 is 1.4, and then, I mean, it's 141, and then you're saying the V escape is also 1. So it's just the same.
V
number.
escape is 1.41 times V circular.
I'm not catching.
oh, us the V escape, so we're putting it into the context to figure out what the, like, I see what you're saying, we're just pretty much substituting.
Okay, but then if you accelerate, if you only do 30% of your V circular,
You'll go into a elliptical orbit. As long as you keep that. So what's going to happen is if you increase it, let's say 30%, this will be your orbit.
okay, that makes sense.
That point is common. It will have to come to that point.
Okay,
You see that?
This statement right here, V escape is equal to root 2. What is that now?
If you are in any circular orbit, okay? Circular orbit, can you be in different circular orbits?
Yes.
Any circular orbit, you increase the speed by 41%, you'll escape.
So every time you
That's
increase
what
by
that's
41%.
That's what that is.
Where's the 41%?
Huh?
Where's the 41%?
What is this? 1.41, right?
So every time you increase by
41%.
Okay.
Increase it by 41% means what? 1.41 times E.
Okay. I just the escape equaling to the V circle is going down. Like, how can you escape being in a circle?
You increase the
So
velocity.
it's saying your V escape is equal to your circular, whatever your velocity is for your circular orbit.
Let's look at the next problem.
With 44% velocity on it.
What are you saying if it goes to,
The next problem.
What is DBF right now?
Huh?
Yeah, design.
Oh, yeah, DBF, okay.
that's